stay here? Yeah. All right, good morning, everybody. We'll be talking about how the real world high performance networking advantages that we have seen and the various comparisons with other technologies and the challenges that we have seen in our financial markets industry. Right, so we'll be talking about our journey.
Indika, I think your phone.
Sorry. All right. So we'll be talking about our journey on how we became the world's fastest trading system in 2010, how we started off early in 2009, and then moving on to a case study on how we upgraded our systems and gave the benefits to our clients. And then moving on to talking about some performance benchmarking tools that we have developed to test our systems. And then various evaluations that we have done on RDMA versus other technologies. And finally, the challenges that we have faced and some questions to the community. All right, so MIT or Milennium IT is a global fintech solutions provider. Specializing in ultra-low latency software systems. So we develop products like trading systems, post-trade systems, surveillance systems likewise. So one of the key things is that we have to be very fast and our systems have to be ultra-low latency for us to stay competitive in this market. So we'll be talking about Millennium Exchange, one of our products, which is a complex distributed system optimized for performance. So moving on to the story. So in the early 2009, we started tuning our systems and we were experimenting with various technologies. We worked closely with Intel and we tried our system on Intel Labs with early Nehalem boxes. And we got 10G networks on the lab and using Blade Networks switchers and NetEffects NICs. And then we used software techniques like tight polling to get our latencies down. So we managed to get the interhop RTT from around 120 microseconds, that's the single hop RTT that we have seen in our local labs, to from around 120 microseconds down to around 34 microseconds in the Intel labs. So that was using Nehalems and 10G. Then we started working with Mellanox and Voltaire to get down the switches into our local labs. And moving on to IB and RNICs. So we implemented the native IB software stack, our layer of it. And then we used 40 gig QDR switches. And using the NICs, we managed to get the overall system latency. So you'll see in the next slides what we mean by that. The overall system latency down to around 100 microseconds, which was a big deal at that time. So this shows how our systems are usually deployed. So it shows certain loops. You have a gateway, then multiple processors taking that input and processing it and sending it out back the gateway. So those are our trading loops. So what this shows is that the network latency plays a significant role in our overall latency. So any benefit we gain out of the network significantly helps us for the overall latency. So after the experiments, we managed to push out the system using further improved hardware. So we went with the Voltaire switches and Mellanox ConnectX 2 at that time. And this managed to get us to the point of being the fastest trading system in production in 2010. So this basically shows how network deployment at that time, we have to have very high availability, so we have redundancies. This is a same thing, logical zoom in, and the exact configurations. So then our journey continues. So from 2010, then we tried to improve it further. So we moved from QDR to EDR, and in 2019 recently, so we upgraded our hardware again. We used EDR-IB. So these are the things we moved on to Red Hat using Intel's Xeon Gold versions. So that helped us and our clients to actually gain significant latency benefits. So this is what we have seen in 2019. So it gives our clients about 50% overall latency gain, which again is a big deal for us. So then my colleague Indika will talk a bit about the tools and the next things that on the agenda.
Hi everybody, this is basically we were heavy users of benchmarking tools to help our application teams to predict certain the behaviors of hardware before they deploy actual applications. Mostly we run network latency benchmarking, multicast tools to check the jitter and drops, because there are something like we send our market data by using multicast, so we are heavy users of multicast systems. So additionally, we test the latencies of disk as well. We use something called D-tool, which we build internally, and later we thought about that something we get together all these tools and implement something which can simulate the real application almost equivalent by certain rules implementing there, rather than before we implement. Sometimes we test by using this new tool called all-in-one. So this is the basic behavior of NW tool. I will just go through what we observe here. If we run the output, usually we get minimum latency per 1 second period, and the average, and as well as the max. So we have min, average and max to compare the variations. So usually it can be run in multiple machines or between different machines to simulate the abstract in terms of network flows. This is multicast network tool, which if you see the output here, we usually check the jitter and the packet losses by this, running on the various speeds, such as this is the message rate, and as well as the message size, which is in bytes. This is D-tool. I just put a real simulation running there with various. We usually get the latencies, disk latencies, by using this tool, and further we analyze the per second bandwidth as well. This is all-in-one. We develop all the previous tools, get together, and improved precision to nanoseconds, and as well as improving from 1 second logs to the individual logs by using this tool, and it can simulate our applications in a different way. Before we develop the applications, sometimes we are running simulations. For an example, there are situations we send unicast to particular host, then get returned by multicast. Those situations we tested by using this all-in-one tool recently developed internally. So this is one of the real situation. We ran the AIO tool between two different hosts. It shows one side is run as writer and otherwise reader or reflector. It shows the average, max and minimum latencies between two hosts. So usually we are heavy users of RDMA and InfiniBand, but still there are clients who are asking different alternative solutions and comparisons to understand whether they should go ahead with InfiniBand or RDMA, or they should initially get into some other technology based on their requirements, latency and as well as performance. So these are the RDMA categories. Right now we have certified, which marked by black. RDMA categories are InfiniBand and Rocky 1 and 2 versions. And non-RDMA, usually we always go ahead on raw Ethernet, and on top of that, SolarFlare Open Onload, which is another commercial solution, and Mellanox VMA. Still, we haven't certified VMA, even though we certified on Open Onload because of our internal testing processes and all those things. And Intel Omnipath, recently we started testing out and got some results. So still the testing and the experiments are going on. And there is another vendor called Exablaze. They have kernel bypass mechanism called Exasoc. We worked on that as well. Still the testing are going on, and the Proforma Myricom now have they have a kernel bypass called EBL run. We work with them as well. So still those are on the experimental levels. So let me go ahead on basic network testing which we are doing, last year we have done the benchmarking for all the different technologies. Let me go into the network side of it. Usually we have different size of message sizes or the byte sizes in our applications. So in average it's something like 500 bytes. So we tested on different message rates against that packet sizes up to 1 million messages per second, and the measured outputs were minimum two-way delay and average maximum, as well as percentile values as well. These are some of the tools we run up, something like NW tool, which provide minimum, average and maximum latencies, and the buffered and remainings. And these are few example table of latencies we were getting with IB. Something like round trip is 2 microseconds, average is almost 2 to 3, and max always below 10. So percentile values we usually use when there is when there are spikes to identify whether it's normal or abnormal in terms of average or the deviation. These are some graphs. I'm not going to explain all of this because there are many in terms of different technologies. So by running the previous series of tests up to 1 million messages per second and 1000 bytes per byte message sizes, these are the criteria we filtered up based on our rule of thumb, or rather our application behavior analysis. Usually we expect minimum average latency up to 5 microseconds, and the average can be maximum up to 7 microseconds to get accepted for our application run. And the maximum latency is defined, the min of max and max of max defined in these values 75 and 100. So by filtering all those different technologies based on this criteria, we identified that EDR, 100 gig EDR and 56 gig FDR, and Rocky 100 and 40G, and SolarFlare Open Onload 40G kernel bypass, all 5 passed the criteria up to 1 million messages per second. And other technologies what we tested last year have some melting points because they break on single sessions. I mean, for an example, Rocky 10G fails at 500 bytes of 1 million messages per second. It doesn't go 1000 bytes per second on 1 million messages. Similarly, we put the descending order on different technologies based on melting points. And this is what usually higher management or our the clients wanted to see as a summary. As I can clearly explain to you, this is RDMA is still the best in terms of low latency, jitter, and scalability benefits and all those things than compared to all others. Still, as we discussed in the morning, better to have interoperability program to improve this lower score in interoperability. So basically, this helps usually to our clients to get overview on when they ask about different solutions for software system. And further, we are now doing different experiments on testing on these different technologies: Omnipath, Cisco US NIC, and our VMA, Exablaze, Exasoc, and Myricom DBL run. And there are layer 1 switches, which is from Atomico, Exablaze, and Exela, which are around, they announced 5 microseconds port to port. We were testing all of these. And there is something called White Rabbit, which is enhancement of PTP, precision time protocol, which is necessary for our troubleshooting and application precisions sometimes, precision measurements. And further, Sampath was last year experimenting on IBM Power, the possibility of promoting it to clients. Still, we are in the process of analyzing the results. And this is what most important for us, because usually we heavily depend on open community as well as industry to provide better solutions to clients. The most recent queries or issues we faced based on this final slide, which is we had recently had a regulatory matter on single point of failure. Usually all the IB NICs between the IB cards, it is impossible to fail over in the network layer because it's implemented by something called automatic path migration. It doesn't support between card at the moment. So we are looking a solution for this, and otherwise we can implement certain things at the software upper layers, but still customers ask this on compliance requirements. It is difficult to justify sometimes. We provide it at different layer, but usually this is sub microseconds if you use APM. So that is one of the things we are trying to solve, and most probably it's better if you can get something, a solution from your side as well. And teaming support for IB, the clients have usually they have something called a mix of 10 gig or Ethernet and IB in their servers. When we usually most of the time, if it is Ethernet, we mostly recommend teaming only because it has user space support and all those things. But unfortunately, GitHub project doesn't, no one is there considered IB in terms of supporting in the project. So we wanted to escalate this and find out a solution whether is there a possibility to improve teaming drivers up to support IB layers. And active bonding is another challenge. Currently we use active passive. So we are working on different solutions. Still none of them worked out to support from the switch levels. And time synchronization between IB host, IB only host, if it is Ethernet is there, then we are fine with PTP support, but in terms of IB only host, certain times we face issues because switches doesn't support boundary clock and all those things in PTP. So that is a regulatory requirement now in Europe after the MiFID II regulation. And IB packet capturing and monitoring at sub-nanosecond level, because sometimes when we are tracing issues or troubleshooting, we prefer to have better timestamps. Currently we depend on Ethernet, something like ERSpan type 3, which is a proprietary solution, and sometimes a TTL field marked with a timestamp. Still there are limitations, like you have to put a marker packet on every to reset the 32-bit timestamp all the time and analyze those. So that is an open question. And reliable multicast, it was always an issue, because multicast itself assumed usually the drops, but in our case it may be a financial loss if you haven't received your multicast feeds properly. So we were looking for solutions to support in terms of Ethernet side. And IB stack, recently we had an issue. We were unable to trace around 1.5 months because of lack of troubleshooting tools. Finally it was able to, because we need to minimize the troubleshooting period or QA analysis periods if we don't have usually better stack to troubleshoot compared to Ethernet. Finally, there is an exponential multi-session latency problem in certain on-load technologies such as Voltaire message accelerator as well as open on-load. Somehow we were able to tune up certain things, but still different message rates, we get something somewhat similar issues. Those are the major things right now. We are looking for solutions. Thank you. Any questions from?
Yes. You had a slide a little while ago called the melting point.
Yes.
I have two questions about it. First of all, what was the actual melt? What do you mean by melting point? What parameter were you measuring?
Okay.
Second, what was the reason for the 10 gig Rocky being double some of the others?
Okay, it's mainly what we are measuring this is what we use, different byte sizes, and message rates are different, and these are all single sessions. Melting points visible only in the single session. If you put multiple sessions, probably you can reach the maximum bandwidth or I mean.
Yeah, I still don't understand what the melting point is.
Melting point is when you are running this, let's say, okay, I will take bottom one. The 500,000 messages per second in 100 bytes. If you put 500 bytes with 500,000 messages, then you are getting higher latencies, which are unexpectable to our levels.
Okay, so when latency begins to rise.
Yes, that's correct.
How much does it need to rise for you to call it a melting point?
Yeah, this is the criteria I put it on. This is what. These are the filtering criteria based on our application.
So the average latency rises above 5, for instance, between 5 and
about, yeah.
It goes about 7.
Yeah, if it is 8.
All right. Okay, good. I understand that a little better now. Okay. Why was the Rocky 10 gigabit solution so much better? What was the root cause of the improvement of why it was so much better?
Okay, still, I mean, I think it's, I tried with different variants, 10 gig, 25 gig, and 100 gig as well in terms of Ethernet. Ethernet doesn't go above, let's say, 400, above 4 GB, I see drops. If you put at any rate, usually I can notice or the higher latencies. high latencies. So,
So you
but
experience too many drops with the other technology?
yes, it's Ethernet purely. You can't go beyond by single session. I don't see it's above 4 GB without higher latencies. But other, if you implement Rocky or the kernel bypass, something like Open Onload, then it's exponentially covers up the latency and the bandwidth as well. You can fool the bandwidth with our tools. So that's the behavior. It may be probably TCP and all those CWIN and other parameters. I was looking something theoretical to calculate this. I have found one of the research done in by New Zealand University, and he built up predictable algorithm to he wanted to predict how much bandwidth you can fill with different message rates and all those things, but still now it's out of date. So there is no universal rule other than what I see is running actually and get the results done.
Well, then I'll just make the observation and I'll ask you if you agree with it, that the oldest and slowest technology on that slide is the fastest, is the best. Why?
You mean
the
Ethernet?
melting point slide.
Melting points.
Well, you know, I see Rocky 10 gig at the top of that pile.
Next slide. No, the next slide. The next slide.
The next slide. You mean this one?
Yeah.
Yeah.
And I see 40 gig stuff, and you know, I see Ethernet adapters. Okay, that's not too surprising. I see EDR half the throughput as Rocky 10 gig. You know, it's like there must be something in the Rocky 10 gig that makes it so much more predictable.
Yes, I'm theoretically not sure, but this is what I observed.
Yeah.
But I have recently seen another thing as well. With this we tested on ConnectX-3, I guess. Now ConnectX-4 4LX, I see it passed the test with all the variables. So probably there is a hardware support as well.
Where's the native IB test? Where's the native IB test?
Native IB test, it's passed.
Those are the best. Those passed all the computers. And the next slide is
With the melting points.
okay. So maybe the green color in the next slide is misleading.
Yeah, this one, right?
Yeah.
Probably I should put red or something. Yes.
Those are fake, right?
So this is the melting point. So up to this point, it works perfectly.
Yeah, but it's not green. It's maybe it's yellow.
Yeah.
Those are the fading technologies. So,
It's up to this. Certain clients, usually there are clients with whole day with 300 orders. So they usually can go up to, they can depend on 1 Gbps as well. But for the clients who have massive rates, need better technology, something like this, yes.
It's not the best, it's just the first to fail.
Yeah, IB is the best, yes. This is, there is a ranking here as well.
Yeah, you probably should flip the order of those two slides.
those was the best. Yeah, those was the best. Those passed all the criteria that they wanted. The next one, the next slide, they're failing somewhere in some of the tests.
Not really. I mean, the technologies here are also there in the second slide, right?
No.
The data is not there.
Okay. Any other questions? So probably you can ask anything on offline. We have different other tools. We do develop, do have something for compliance and tuning verifications as well. In a single click, you verify all the tunings done according to the low latency parameters and all those things. Probably Sampath, probably we can think about putting open source some of these tools, because that's something we can discuss as well. So
By the way, I think that Rocky 10 gigs can pass through so so much bandwidth above this point, right?
Yes.
I think it's
Yes.
it's the line rate.
Yes, that's correct.
You reach the line rate of 10 gigs, something like that. So
I initially assumed that, but when
you sent 1 million packets per second, and the threshold was 500.
yeah,
So you've reached 5 gigabits per second, something like that.
yeah, that's
Something
correct.
like 5. So if
So-
you go beyond that, you reach 10 gig. So
that may be the reason, but as I said, the ConnectX 4LX passed the threshold, even 500,000 with 1,000 bytes. So, thank you very much. Then,
One comment for your automatic path migration. I think if you check the MPI code, you
Okay.
will see that it's not dependent on the ports. So you can do a link-based path migration, and then it's just destination lists. So check the OpenMPI code. I think it's not that those two ports have to be attached to the same NIC. So
okay.
you can migrate between multiple NICs and in the same node.
Okay, recently I tested on bonding driver. Somehow we predicted it will never fail over between together. Somehow it has gone through within 25 seconds, which is not acceptable at all. But let me check. Yeah, thank you. Thank you very much.